Hi, welcome to this Corbettmaths video. In this video, we're going to look at how to write the logs of numbers in terms of the logs of prime numbers. So if you're studying for GCSE Further Maths, particularly the CCEA GCSE Further Maths, there's been questions where you've been asked to write the log of a number in terms of the logs of other prime numbers. And whenever we look at this topic, it's quite useful to know the laws of logarithms. That's the fact that log A plus log B is equal to log AB. The log A minus log B is equal to log A over B. And also that if we have a log of A to the power of n, we can bring the power down so it would be equal to n times the log of a. So those laws of logarithms are going to be quite useful whenever we write these log of numbers in terms of the logs of prime numbers. Okay, so let's have a look at some questions to begin with, and as we go through these questions I'll talk about how we approach them. Okay, let's have a look at our first question. So our first question says, if log 3 is equal to a, log 5 is equal to b, and log 7 is equal to c, we've been asked to express the following in terms of a, b, or c. So here we've got that log 3 is equal to a, and that's log to base 10 of 3. Now obviously whenever it's base 10 we just write log 3, so we've got log to base 10 of 3 is equal to a, log to base 10 of 5 is equal to b, and log to base 10 of 7 is equal to c. And again, we're not writing the tens because we know that if we just write the log of 3, that's log to base 10 of 3. Okay, so let's have a look at our first one. Our first one we've been given is log 15. So we want to write log 15 in terms of a, b, and or c. Now here if we have a look at a, that's equal to log 3, and b is equal to log 5. Those two are going to be very useful because 15 is 3 times 5. And what can be quite useful in these questions is the number that we're trying to do the log of, if we consider the product of primes, that can be quite useful. So 15, if we have a look at 15, 15 is equal to 3 times 5. Some people do the prime factor trees, or some people do the upside down division method to get it as a product of primes. Remember, it is a calculator paper, so on your calculator you can actually type in 15 and then select product of primes, and it'll just tell you it's 3 times 5. So here we've got the log of 15. So log 15, well, I'm going to write it, instead of log 15, I'm going to write the log and then in brackets of 3 times 5. And I've chosen those numbers because in the question we were told the log of 3 is equal to a and the log of 5 is equal to b, so they're going to be quite useful. So I've just considered 15 as a product of primes. Now we've got log of, and then we've got 3 times 5. Now remember, if we go back to our laws of logarithms, log AB is equal to log A plus log B. So we can split up that log. We can, instead of writing log of 3 times 5, we can say that's log 3 plus log 5. Because if we had log 3 plus log 5, we would times the 3 and the 5 together to give us 15. So we're splitting that up into log 3 plus log 5. Now if we have a look at the question, we were told that log 3 is equal to a, so log 3, that's a, so a, and then log 5 is equal to b, so plus b. So that means that log 15 would be a plus b, and that's it. So we've expressed log 15 as the log of prime numbers, and it would be a plus b, and that's it. Okay, let's have a look at our next one, log of 21. So log of 21, well, think about 21. 21 is equal to 3 times 7, so 3 times 7. So what I'm going to do is, if we have a look here, we've got log of 3 and the log of 7, so they're going to be quite useful. So I'm going to write log, and instead of 21, I'm going to write 3 times 7. And then we would split that up into log 3 plus log 7, because remember log 3 plus log 7 would be log 21, so log of 21 will be log 3 plus log 7, and then log 3, that's equal to a, and then log 7 is equal to c, so it would be a plus c. So log 21 will be equal to a plus c, it would be log 3 plus log 7, so we've expressed this log of 21 as the log of prime numbers, and that's it. So we've expressed this log of 21 in terms of a and c, so that's it, a plus c. Okay, so let's have a look at some more. So here we've got that a is equal to log 3, b is equal to log 5, and c is equal to log 7. And this time we've been asked to express in terms of a, b, and or c, log of 105. So here we've got 105. So what I'm going to do is I'm going to write this as a product of primes just to see what 105 would be. And again, it's a calculator question, so you can just type in 105 and then do the product of primes for that, and it tells you it's 3 times 5 times 7. So 105 is equal to 3 times 5 times 7. You could do, if you wanted to, your prime factor tree with 105, and then it would be 15 times 7, 7's prime, circle it, and 15 you would then do 3 and 5, and again circle those, that's 3 times 5 times 7. Or remember, you can do 105, and then some people do this where they think 105 is divisible by, let's just choose 5 perhaps, that's going to be 21, and then you can divide that by 3, and that's equal to 7, and then divide by 7, and then you get that's equal to 1, and again that's 5 times 3 times 7. So whichever way you want to do the product of primes, that's totally fine. So I'm just going to get rid of that a second, so let's just get rid of that. We don't need the method, we just need the answer. So 105 is equal to 3 times 5 times 7, so we've got log of 105. Well, we know the log of 3, we know the log of 5, and we know the log of 7. So what I'm going to do is I'm going to write the log of, and instead of 105, I'm going to write 3 times 5 times 7. And then we're going to split this up. So this would be the log of 3 plus the log of 5 plus the log of 7. Because remember, thinking of our laws of logarithms, the log of AB is equal to log A plus log B. So if you had the log of ABC, that's going to be the log of A plus the log of B plus the log of C. Okay, just splitting that up. So here, we now know we've got the log of 3 plus the log of 5 plus the log of 7. Well, log 3, well, that's going to be A. Log 5, that's going to be B, so plus B. And then plus log of 7, that's going to be C. So that'd be A plus B plus C. So we've expressed the log of 105 in terms of A, B, and C. It's just A plus B plus C, and that's it. Okay, let's have a look at our next one. Our next one is to write the log of 0.6 in terms of A, B, and C. Now here we've got a decimal number, so what I'm going to do with this, if I've got a decimal such as this, what I'm going to do is I'm going to write it as a fraction to begin with. So 0.6. 0.6 as a fraction would be equal to 3/5. And again, it's a calculator paper. If you type in 0.6 and press equals, your calculator may just write it as a fraction for you, or you should really know that 0.6 is 3/5 anyway. So what I'm going to do is I'm going to write log of, and instead of 0.6, I'm going to write 3/5, like so. Now if we have a look here, we've got 3 and we've got 5. That's fantastic. They've been given to us. So I'm now going to split this up. Remember that log A over B will be equal to log A minus log B. Going back to our laws of logarithms, that log of A over B is equal to log A minus log B. So here I'm going to write this as log 3 minus log 5. So that's going to be log 3 subtract log 5. And the log of 3, well, that's A. And then the log of 5, that's B. So the answer would just be A minus B. And you can check if you're right. You can get your calculator and do the log of 3 subtract the log of 5, see what that answer is, and also do the log of 0.6 and see if you get the same answer, and then you'll know that you're right, that it is A minus B. Okay, so let's have a look at our next one. So again, we've got that A is equal to log 3, B is equal to log 5, and C is equal to log 7. And we've been asked to express the log of 75 in terms of A, B, and or C. Okay, so this time what I'm going to do is I'm going to write 75 as a product of primes. So 75 would be equal to 3 multiplied by 5 multiplied by 5. Because 5 times 5 is 25, times 3 would be 75. Or we can actually write it as 3 multiplied by 5 squared, because 5 times 5 is 5 squared. Okay, so log 75, well, I'm going to write that as the log of, and instead of 75, I'm going to write 3 multiplied by 5 squared. Okay, now this is fantastic because if we have a look here, we've got the 3, and remember that log 3 is equal to A, and we've got 5, and log 5 is equal to B. So what I'm going to now do is split this up into log 3 plus the log of 5 squared. Because remember that log AB would be log A plus log B. So because these are just two things multiplied together, we can split them up. So we've now got log 3 plus log of 5 squared. And I'm going to bring the 2 down, because remember if you've got a power, you can bring that down. So it's going to be the log of 3 plus, I'm bringing the 2 down, 2 log 5. And then finally, we know that log 3 is equal to A, so it's going to be A, and then plus, and that's going to be 2 times log 5. Log 5 is equal to B, so it's going to be 2 times B, so 2B. So that means that log 75 is equal to A plus 2B. And again, you can check that out. You can, on your calculator, do the log of 3 plus 2 times the log of 5, and check and see if that's the same as the log of 75, and it will be. And that's it. Okay, let's have a look at our next one. So our next one is the log of 1,225. And again, we need to express that in terms of A, B, and or C. Okay, so 1,225, I'm going to write that as a product of primes. So I'm actually just going to use my calculator for that. So I'm going to type in 1,225 and press equals, and then go and select product of primes. And that's equal to 5 squared multiplied by 7 squared. And that's fantastic because we've got the 5, we've got the 7, so that's great. Okay, so the log of 1,225, that's the same as the log of, and then 5 squared multiplied by 7 squared, close brackets. Now we're going to split this up into the log of 5 squared plus the log of 7 squared, just splitting this up where we've got the multiplication sign, just split it up into the log of 5 squared and then plus the log of 7 squared. Okay, now we've got some powers, so let's bring those down. So the 2, let's bring it down to be 2 log 5. And then plus, I'm bringing the 2 down, 2 log 7. So that's fantastic. And then finally, we've got this log 5 is equal to B and log 7 is equal to C. So it's going to be 2B plus 2C. So 2B plus 2C. And you could, if you want to factorize it, to say it's the same as 2 brackets B plus C, or you could just leave it like that, 2B plus 2C, or 2 bracket B plus C. And that's it. Okay, let's have a look at our next two. So again, we've got the log 3 is equal to A, the B is equal to log 5, and C is equal to log 7. And this time we need to express the log of 1.4 and log of 0.12 in terms of A, B, and C. Okay, so let's start off with the log of 1.4. So 1.4, I'm going to write that as a fraction. 1.4 is equal to 7/5. And again, you can check that in your calculator, type in 1.4, press equals, and it probably will come up as 7/5. Or if you think about it, 7 divided by 5 is 1.4. So I'm going to write that as the log of 7/5 because 1.4 is 7/5. This is fantastic because we've got the 7 and the 5, and if we have a look here, we've got 7 and 5. So we've got the log of a over b, remember is log a minus log b, so let's split this up. This would be the log of 7 subtract the log of 5. And the log of 7, that's going to be c, and the log of 5, that's going to be b, so the answer would just be c minus b. So that's it, the answer is c minus b. Okay, let's have a look at our next one. Our next one is to work out the log of 0.12. So I'm going to write the 0.12 as a fraction. Now 0.12, you could write 12 over 100 and simplify that, or you could just type in your calculator 0.12 is equal to 3/25. Again, you could write it as a 12 over 100 and cancel that down, and that'd be 3/5 as well. So we've got the log of 0.12. Well, I'm going to write it as the log of 3/25 because 0.12 is 3/25. So I'm just writing that as a fraction. Now here we've got 3, that's fantastic, we want the 3 there, but we've got 25 on the denominator. Now 5 squared is equal to 25, so I'm going to write it as the log of 3 over 5 squared, just replacing the 25 with 5 squared. Now this is fantastic, we can now write this, because we've got our 3 and our 5, we can split this up into the log of 3 subtract the log of 5 squared. And then we can bring down that power, we can bring down the 2, so it's going to be the log of 3 subtract, bringing down the 2 log 5, so 2 log 5. And then finally, log 3, well log 3 is equal to a, so that's a minus, and then 2 times log 5 is equal to b, so it's going to be 2b, so 2b. So that would be equal to a minus 2b. Okay, let's have a look at the next one. Okay, so our next one, I've changed this slightly now because it's not always going to be the log to base 10, just log. We're going to have, in this case, we've got log to base 11 of 2 is equal to a, the log of base 11 of 3 is equal to b, and the log of base 11 of 5 is equal to c. And we've been asked to express the following in terms of a, b, and c. So we want to write these logs of these numbers as logs of prime numbers. Okay, so let's have a look at our first one. We've got the log to base 11 of 30. Well, 30, if we think of 30, or you can consider your product of primes, 30 is equal to 2 multiplied by 3 multiplied by 5, because 2 times 3 is 6 times 5 is 30. So what we're going to do here is we're going to write the log to base 11, and instead of 30, I'm going to write 2 times 3 times 5, close brackets. Now we can split this up, because remember the log of AB is equal to the log of A plus the log of B, or the log of ABC would be equal to the log of A plus the log of B plus the log of C. So this would be equal to the log to base 11 of 2 plus the log to base 11 of 3 plus the log to base 11 of 5. And now we know what these are, because the log to base 11 of 2, that's A, so we've got A, plus the log to base 11 of 3, that's equal to B, so B, plus the log to base 11 of 5 is equal to c. So that's it. So that would be a plus b plus c. So the log to base 11 of 30 is a plus b plus c. And again, you can check it on your calculator, type in the log to base 11 of 30 and see what you get, and then do the log to base 11 of 2 plus the log to base 11 of 3 plus the log to base 11 of 5, and you should get the same answer. Okay, let's have a look at the next one. So this time we've got the log to base 11 of 40. So let's write 40 as a product of primes. 40 is equal to 2 cubed, which is 8 times 5. 2 cubed is 8 times 5 is 40. Fantastic. So that means the log to base 11 of 40 would be, well, let's write the 40 as log to base 11 of 2 cubed multiplied by 5. Just writing 40 as its product of primes. Now we're going to split this up. So this would be the log to base 11 of 2 cubed plus the log to base 11 of 5, because remember, if you have the log of AB, that's the log of A plus the log of B, so just splitting this up. Now here, if we have a look here, we've got a power, this is 2 cubed, so let's bring the 3 down, so that'll be 3 log to base 11 of 2 plus the log to base 11 of 5. And then finally, we know that the log to base 11 of 2 is equal to a, so this will be 3 times a, so that'll be 3a plus, and then we've got log to base 11 of 5, that's equal to c. So that'll be 3a plus c, and that's it. So the answer would be 3a plus c. Okay, let's look at our next one. Okay, this time, if we have a look here, we've got log to base 11 of 540, so it's quite a big number, so let's write it as a product of primes. 540, I'm going to use my calculator for this, so 540, press equals, and then choose my product of primes, is equal to 2 squared times 3 cubed times 5. So I'm going to write this as the log to base 11 of, and then in brackets, 2 squared times 3 cubed times 5, because that's equal to 540. Now let's split it up into the individual logarithms. So we've got the log to base 11 of 2 squared plus the log to base 11 of 3 cubed plus the log to base 11 of 5. Okay, now let's bring down the powers. So bringing down the 2 and bringing down the 3, we'd have 2 log to base 11 of 2 plus 3 log to base 11 of 3, and then plus the log to base 11 of 5. And then finally, we now just want to replace the log to base 11 of 2 with a, so that'll be 2a plus, and then the log to base 11 of 3 is b, so that'll be 3b, and then plus, and then this is just c, log to base 11 of 5 is c, so the answer would be 2a plus 3b plus c. Okay, next, we've now got the log to base 11 of 1.5. So the 1.5 is a decimal number, so I'm going to write that as a fraction. 1.5 as a fraction is 3/2, so 3 over 2. So that's fantastic, because if we have a look here, we've got the log to base 11 of 3 and the log to base 11 of 2. So it's not a coincidence it's equal to 3 over 2. So I'm going to write this as the log to base 11 of 3 over 2. Okay, now we've got the same as log a over b is equal to log a minus log b. So this would be the log to base 11 of 3 minus the log to base 11 of 2. Just splitting this up into log a over b is equal to log a minus log b. And then finally, we know the log to base 11 of 3 is equal to b, so that's b. And then it's going to be minus the log to base 11 of 2 is equal to a. So the answer is b minus a. And that's it. Okay, let's have a look at our next question. Okay, again, we've got the same values of a, b, and c, and we want to write, in terms of a, b, and c, the log to base 11 of 0.6. So let's write our 0.6 as a fraction. 0.6 would be equal to 3/5, and that's great, because if we write this as the log to base 11 of 3/5, because this is great because we've got our 3 here and our 5 here, so we can split this up into the log to base 11 of 3, subtract the log to base 11 of 5. That's the log to base 11 of 3, subtract the log to base 11 of 5. Okay, now this is equal to b, so that's going to be b. Subtract the log to base 11 of 5 is c, so the answer would just be b minus c. Okay, our next one, the log to base 11 of 0.8. So 0.8 is equal to 4/5. Now here, if we have a look here, we've got our 5, that's fantastic, but 4, well, we've only got 2, but 2 squared is equal to 4. So I'm going to write this as the log to base 11 of 4/5. Now here the 5 is fantastic, but this 4, it's not as helpful, but we've got 2, so 4 is 2 squared. So I'm going to write the log to base 11 of 2 squared over 5, because 2 squared is 4. Okay, now let's split this up, because we have the log of a over b is equal to the log of a, which would be the log to base 11 of 2 squared, subtract the log to base 11 of 5, just splitting this up. Now let's bring down our power, that 2, let's bring that 2 down, so it'll be 2 log to base 11 of 2 minus log to base 11 of 5. And this is fantastic, because we know the log to base 11 of 2 is a, and the log to base 11 of 5 is c, so we can then just write this as, instead of 2 times this, it would be 2a, so 2a, subtract, and then this would just be c, and that's it. So the log to base 11 of 0.8 would be 2a minus c. Okay, let's look at our next one. Okay, now let's have a look at our next ones. Now these ones are a little bit different than the ones we've looked at so far, because so far we've been dealing with our 2, our 3, and our 5. Now if we have a look here, we've got log to base 11 of 33. Now 33 as a product of primes would be equal to 3 times 11, because 3 times 11 is 33. Now that's not a coincidence, this 11 is the base. So sometimes, rather than it being the 2, the 3 or the 5 we're looking for, in this case we're also looking for the 11, that can be quite useful as well. So here, if we have the log to base 11 of 33, that's the same as the log to base 11 of 3 times 11. Now we can split this up, this would be the log to base 11 of 3 plus the log to base 11 of 11. So sometimes you might be actually dealing with the base number as well. So here we're dealing with this 11. Now the log to base 11 of 3, that's equal to b, so it's equal to b there, so b. And then The log to base 11 of 11, well, we think what power do you raise 11 by to get 11? That'd just be 1. So the log to base 11 of 11 is 1. And just think about the log to base a of a is equal to 1 as well, so that'd be 1. So the answer is b plus 1. And you can check it. If you do the log to base 11 of 3 and add 1, you should get that's the same answer as the log to base 11 of 33. And that's it. So sometimes, rather than looking for, in this case, the 2, the 3, and the 5, we may also sometimes be looking for the 11 as well. So that might be involved, the base of the logarithm. Okay, so we've got the log to base 11 of 55. So 55 is equal to 5 times 11. So this would be the log to base 11 of 5 times 11. The log to base, now we split this up into the log to base 11 of 5 plus the log to base 11 of 11. Okay, so the log to base 11 of 5, that's equal to c, so that's c, plus the log to base 11 of 11, well, what power do you raise 11 by to get 11? That'll be 1, so that'll be c plus 1. So that's it. And again, you can check your answer. If you do c, which is the log to base 11 of 5, and add 1, you should get that's the same answer as the log to base 11 of 55. Okay, let's look at 2 more. Okay, so this time we've been asked to express these in terms of a, b, and c. So we've got the log to base 11 of 1.2. Well, let's take our 1.2 and let's write it as a fraction. So 1.2 is 6/5, so 6/5. So I'm going to write this as the log to base 11 of 6/5. Now we've got 5 on the denominator, that's fantastic. But we've got a 6 on the numerator. Now here, actually 2 times 3 is equal to 6. So I'm actually going to write this as the log to base 11 of 2 times 3 over 5. Just writing the 6 as 2 times 3. Okay, now what I'm going to do is I'm now going to split this up. So this will be the log to base 11 of 2 times 3, subtract the log to base 11 of 5. And again, split this part up. And again, let's split this bit up. So this will be the log to base 11 of 2 plus the log to base 11 of 3, and subtract the log to base 11 of 5. And now finally, we just need to replace them. So the log to base 11 of 2, that's a, plus the log to base 11 of 3 is b, subtract the log to base 11 of 5, that's going to be c. So the answer would be a plus b, subtract c, and that's it. And again, you can check your answer. If you do the log to base 11 of 2, add the log to base 11 of 3, and subtract the log to base 11 of 5, you should get that's equal to the log to base 11 of 1.2. Okay, let's look at our next one. So we've got the log to base 11 of 7.5. So 7.5 is equal to 15 over 2, or 15 halves. Okay, so 7.5 is equal to 15 halves. So that's the log to base 11 of 15 over 2. Now the 2 on the denominator is fantastic, but we've got 15 on the numerator. Now 15 is 3 times 5, so that'll be the log to base 11, and instead of 15 we're going to write 3 times 5 on the numerator, divided by 2. Okay, now let's split this up. So this will be the log to base 11 of 3 times 5, subtract the log to base 11 of 2. And again, let's split this up into the log to base 11 of 3 plus the log to base 11 of 5, subtract the log to base 11 of 2. And then that just would be, well, this would be b, plus this bit would be c, subtract this bit, which is a. So the answer is b plus c, subtract a. And that's it. Okay, let's have a look at 2 last questions. So we've got the log to base 11 of 12.1 and the log to base 11 of 49.5. Okay, so let's start off with this one. So 12.1. So 12.1 as a fraction, 12.1 as a fraction would be equal to 121 over 10. So 121 over 10. Now, if we have a look at this, 121, well, we've got 2, 3, and 5, and then also we've got the base, which is 11. 11 squared is 121, so this is actually quite useful. And 10, well, 2 times 5 is 10. Okay, so we can work with this. So we've got the log to base 11 of 121 over 10. And then we're going to write that as log to base 11 of 11 squared on the numerator and 2 times 5 on the denominator. And let's split this up. So we'd have the log to base 11 of 11 squared, subtract the log of 2 times 5, close brackets. Okay, so we've now got the log to base 11 of 11 squared, subtract log to base 11 of 2 times 5. Okay, so let's bring the power down, so that'll be 2 times log to base 11 of 11. Okay, and now we're going to split this up. Now, because we're subtracting here, what I'm going to do is I'm going to split it up in our bracket here. So I'm going to write the log to base 11 of 2 plus the log to base 11 of 5, because the log to base 11 of 2 plus the log to base 11 of 5 will be the log to base 11 of 10. But we are subtracting, so I'm just keeping this in a bracket so that I know that I'm subtracting this and I'm subtracting that. Okay, so let's write that out. That's going to be 2 times the log to base 11 of 11, subtract the log to base 11 of 2, subtract the log to base 11 of 5. Because you're subtracting both of these, or some people consider it as -1 times that and -1 times that, and that's why they both subtract there. Okay, now let's then replace these. So we've got the log to base 11 of 2, that's going to be A, so that's A. The log to base 11 of 5, that's C. And then here we've got the 2 times the log to base 11 of 11. So what power do you raise 11 by? To get 11, that'll be 1. And we've got 2 times 1, which would be 2. So we've got 2. So let's just scroll down a little bit there. So this bit's 2. 2 times 1 is 2. And then we had log to base 11 of 2. And the log to base 11 of 2 is A. So subtract A. And then subtract the log to base 11 of 5. If we go back up there, that's equal to C. So the answer would be 2. Subtract A. Subtract C. Okay, let's have a look at our last question. Our last question is to work out the log to base 11 of 49.5. So we've got 49.5. And we want to write that as a fraction. So because it's half, it's going to be over 2. And it would be 99 over 2. So 99 over 2 is equal to 49.5. So it'll be the log to base 11 of 99 over 2. Now here we've got our 2, that's fantastic, but we've got 99 on the numerator. Well, 99 is equal to 3 squared times 11, because 3 times 3 is 9 times 11. So let's write that down. That's the log to base 11 of 3 squared times 11 over 2. Okay, so let's split this up. So we've got, and that's fantastic because we've got our 3, we've got an 11, that's fine, and we've got our 2 as well. So it's going to be the log to base 11 of our numerator, 3 squared times 11, so close brackets, subtract the log to base 11 of 2. Okay, now let's split this up as well. So we have the log to base 11 of 3 squared plus the log to base 11 of 11, subtract the log to base 11 of 2. And then finally, let's bring that power down. So it'll be 2 log to base 11 of 3 plus the log to base 11 of 11, subtract the log to base 11 of 2. Okay, well, this bit's equal to 1. 2 times the log to base 11 of 3. Well, log to base 11 of 3 is equal to b. So this would be 2 times b. So that's going to be 2b. This bit's equal to 1 because what power do you raise 11 by to get to 11? That's 1, so it'll be plus 1. And then we've got to subtract the log to base 11 of 2. Well, the log to base 11 of 2 is a, so it's going to be subtract a. And that's it. So that's it. So in this video, we've looked at how to write the logs of numbers in terms of the log of prime numbers. The laws of logarithms will be very useful for that. So knowing these laws of logarithms, we used all of them here. We actually split up our logarithms into log a plus log b. And we split up our logarithms that were fractions into log a minus log b. And we also brought down some powers as well. And in terms of these questions, I would just say practice them. And they're quite straightforward actually once you practice them. And being able to write numbers as a product of primes will be quite useful as well. And if you've got a decimal number, it can be quite useful to write that as a fraction. And that's it. So I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.